Greetings. This is John Shribs at Casa Grande High School, and there is a problem in the Miller and Spoolman textbook, Living in the Environment, 17th edition for AP Environmental Science students, particularly a problem in Chapter 4 that some folks may have trouble with. So this is question number 11, which is a math-based problem. So I thought I'd go ahead and show you how to solve this. This problem is fairly detailed. It tells us that atrazine is a herbicide that controls weeds, and it blocks photosynthesis through its mode of action, and is frequently cited as a source or cause of mutations in frogs and other amphibians. Atrazine is often applied at rates of 2.9 times 10 to the 7th parts per billion. And this is essentially about 4 pounds per about 20 gallons of water that's put into a spray tank here, and then coming down a boom to the field, and then sprayed onto the field out of the spray, right out of this boom right here. And that's as the tractor is moving down the road in a forward direction. So that's where this 2.9 times 10 to the 7th parts per billion comes from. It's from the concentration in the spray tank of the solution in the tractor. So, but the EPA has set a limit for atrazine in drinking water, which is at 3 parts per billion. That's a lot lower level than the 2.9 times 10 to the 7th parts per billion in the spray tank. So we don't want to be drinking that water. Now a farmer is going to be applying this atrazine on a field at a rate of 4 pounds per acre, and sprays an average farm, let's say, about 1,000 acres. Now atrazine is a corn herbicide that controls both broadleaves and grasses, and is used extensively throughout the Midwest, and is sometimes blamed for the dead zone at the end of Mississippi, which also is a combination with the fertilizers that's causing that. But atrazine is a potential confounding factor, and so we want to study the atrazine coming off the soils in the Midwest and the cornfields, which is why this problem is here. So it's actually a real situation with a real problem that we need to investigate. So the question now, here's where this problem is. It's how many gallons of water would it take to essentially bring the contamination level of the spray tank down to, or on this acreage, down to 3 parts per billion to get it under for drinking water quality. And we're given extra information that 1 gallon of water is going to weigh 4.38 pounds. So dissecting this problem, we really don't need much of the information that's above. So right up here and above is extra information that we're being given that's not needed in the current problem to solve this particular problem, but we're given this information as part of our scenario. So many times we have to tease out what the issue is, what the problem is, from the scenario. So on our next slide here, what is given? First off, atrazine is a herbicide. It controls weeds in corn. It has a spray tank concentration of 2.9 times 10 to the 7th parts per billion. Again, that's close to 4 pounds per about 20 gallons of water that's in the spray tank. And drinking water, 3 parts per billion is what's accepted in the contamination. So you can still drink that water below 3, but illegal above 3. And what is 1 part per billion? That's not parts per million, it's parts per billion. That is 1 part per 10 to the 9th. That's 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros out of it. So 1 part out of a billion. Now the rate of application for atrazine to control weeds is about 4 pounds of chemical, of active ingredient, for every acre of the field. And we're multiplying this by 1,000 acres for the total quantity of chemical applied by an individual farmer. And then we have the extra information. 1 gallon equals 8.34 pounds. So our next thing is, what is it we want to find, and then we can go about solving the problem. Okay, so we're looking for how much water, amount of water, and we want to get to 3 parts per billion. How much water is it going to take to essentially decontaminate this field so that the water in the field is essentially drinking water? Okay, that's a different way of looking at these types of problems. But let's go ahead and solve the problem. Okay, the first step, 4 pounds of atrazine and to how many pounds of water will it take for this to equal 3 parts per 10 to the 9th parts of water. So there's 3 parts of atrazine to 10 to the 9th parts of H2O, of water. So just extend this out. So now we need to solve for X in this ratio here, and then eventually turn that into gallons from pounds. Because parts per million, it's based on parts per parts, pounds per pounds. So let's go ahead and solve for X. So X is equal to 4. Oh, and we have to include in this, we're multiplying this by 1,000 acres up here, total. So let's include that. So let's simply do that. We now have 4,000 pounds of atrazine that we have to deal with. Not just 4,000 pounds. At 4,000 pounds and times 10 to the 9th divided by 3, and that is going to equal 1.3, this little line goes over the top from the calculator, times 10 to the 12th pounds. So this is how much water, H2O, we're going to need, is 10 to the 12th pounds of water to dilute the original 4,000 pounds of atrazine that we're applying to these fields. That's a lot of atrazine. That's pretty expensive. So what is our next step? Okay, now we have to translate pounds into gallons. So we start off with 1.3 times 10 to the 12th pounds, and just use, we put this over 1 and multiply it by our conversion factor. And what is our conversion factor? It's back over here, right here. So we put pounds below, and we put gallons up above. There's 8.3 pounds of water for every 1 gallon of water. And so by using this conversion factor, we end up with 1.60 times 10 to the 11th gallons of water is going to be needed to dilute it. And this amount of water, from the problem from the ABC choices, is going to be approximately the size of a large lake in New York, one of the Finger Lakes.